So let's take a look at this example where the safety of airplane drinking water, conducted by the U.S. Environmental Protection Agency, did a study where they found that in a random sample of 316 airplanes tested, 40 had bacteria in the drinking water. They also know that as a benchmark, about 3.5% of the U.S. population has bacteria-infected drinking water. So what we want to do is ask the question or test the claim about whether or not we can conclude that drinking water on airplanes is more contaminated than drinking water in general. So let's go over to StatCrunch here, and because this is a proportion hypothesis test, we're going to go to Stat, then Proportion Tests. We have one single sample, and we have a summary of that data. So notice here the number of observations is pretty plain. It's 316. So we'll type that in. And we're testing to find out what proportion, we're testing rather, whether or not the proportion of drinking water on airplanes is more contaminated than drinking water in general. So a success here means that you have actual contamination on a particular data for a particular data point. So the number of planes where there was contamination is 40, and so therefore that corresponds to a success in this situation. So 40 out of 316 are contaminated. So success here is interpreted weirdly. Success is contamination, which is a bit odd, but keep in mind that that word success is a very general term that we use here. Okay, now we're trying to test whether or not this particular sample has a proportion that's greater than the general population. And the general population is said to have a 3.5% rate of contamination. So we're basically saying, let's assume for the null hypothesis that there's nothing out of the ordinary going on here. So our proportion here is going to be 3.5% or 0.035 when we convert it to a decimal. Because we're trying to test the claim of whether or not the drinking water on airplanes is more contaminated, the alternative hypothesis is going to be a greater than, include a greater than symbol. So if we reject the null hypothesis, then we'll have enough statistical data to conclude and to accept the alternative hypothesis, which says that yes, airplanes do have a higher proportion of contamination than the general population. So when we go ahead and click compute here, let's see what we get. What's important here is our z statistic, which is 8.8. So this is telling me that this sample is 8.8 standard deviations higher than what we would expect. And because of that, it's way out on the right side. And so the likelihood or the probability of that sample taking place, given the null hypothesis is true, is very, very small. So when we go to interpret this, what we're saying then is that we have enough statistical information here to reject the null hypothesis. So we reject this hypothesis here, which allows us to accept this alternative and conclude that we have enough statistical data to indicate that the population, or rather the drinking water on airplanes, is more contaminated than the drinking water in general.